In the previous lecture, we started with solving system of linear equations. I'll just recall the important things that I'll write down the augmented matrix for the given system of equation. We'll reduce this matrix to echelon form. Once the matrix is reduced to echelon form, we will look at three conditions. If the rank of augmented matrix is equal to rank of A, which is equal to number of variables. Number of variables, then system has unique solution. If the rank of augmented matrix is equal to rank of A and it is less than number of variables, then it has infinitely many solutions. And the third case, if rank of augmented matrix is not equal to rank of A, then the system has no solution. Now, for infinitely many solutions, what we do is, if rank of augmented matrix is equal to rank of A is equal to R and it is less than n, the number of variables, then we say that n minus R variables are free. N minus R variables are to be free. What we do is, for the free variables, we put them as say R, S, T or something like that, and then we solve the system. This is the way we find out the solutions for the system of linear equations. We have solved enough number of examples on this, and now we will go for different types of examples, in which the first one is find for what value of k, values of k, the system two x minus 3y plus 6z minus 5t is equal to 3, y minus 4z plus 1 plus t is equal to 1, and the third equation is 4x minus 5y plus 8z minus 9t is equal to k has A, no solution, B, infinite solution. So the question says that I need to find out the value of k, where is k is this. So I have to put some condition on k in such a way that the system will have no solution or it will have infinitely many solutions. So what can we do? Anyone? What do you think?
सर ऑगमेंटेड मैट्रिक्स लेके नॉर्मल फॉर्म में कन्वर्ट करके फिर इक्वेट कर देंगे.
Okay. Normal form or echelon form?
Sir, echelon form में. Sir, echelon में.
So what we will do is we'll write down the augmented matrix, reduce it to echelon form, and then we will observe for what values of k it is the system is having no solution, or for what values of k it is having infinitely many solutions. So I'll directly write down the augmented matrix here. So augmented matrix AB is equal to, now we have four variables: 2, -3, 6, -5, 0, -4, oh sorry, +1, -4, 1. There is 3, 1. The last row is 4, -5, 8, -9. The center is k. So the augmented matrix. No need to make A11 entry as 1 because I can use that 2 and make the entry 831 entry 0. So R3 minus 2 times R1. What do we get? 2 -3, 6 -5. Then you have 0, 1, -4, 1. Both the entries are 1. 4 minus 2 to 0. -5 minus +6, that is 1. Then this will be -4. This is again 1. And you have k minus 2 into 3, 6. So this will be k minus 6. Now, all the below entries are 0. I will go to A22. I'll make the below entry to this A22 entry 0. So that is R3 minus R2. So the new matrix that we get is 2 minus.
So in the fourth column, it's 3, 1, k minus 6.
3k minus 6.
No, 3, 1, k minus 6. Fourth column.
No, it is. I think it is correct.
Sir,
No, sir.
row first, column fifth.
Sir,
Just-
first
Fifth
row,
column
last.
of first row. It should be 3.
Fourth column.
Just a minute. This entry you're saying?
No,
The
column 5 and row 1.
Sorry,
Column.
sir.
Column first row.
Fifth column.
Okay, this entry you're saying. Okay,
Yeah, it should be
I
3.
said fourth column by mistake.
yeah. Thank you. This is 3. This will be 0, 1, -4, 1, 1. That is 1 minus 1, 0 minus 4 plus 0, 1 minus 1, 0 minus k minus 6 minus 1. That is k minus 7. Now, the augmented matrix is reduced to echelon form. This is our echelon form now. Now, in this k minus 7 will define the order. I mean, rank of the matrix. So, if k is not equal to 7, then the rank of augmented matrix is 3, and the rank of A will become 2. Since there are only 2 non-zero rows in this, so system will have no solution. Has no solution. Now the next question is, if k is equal to 7. So I'll just rub this part. So if k is equal to 7, then the rank of A is equal to rank of augmented matrix, which is totally is equal to 2. So system will have so
Consistent solution.
consistent but infinitely many solutions. System is
Yes.
consistent with infinitely many solutions. And that's it. So the question was to find out put the condition on k in such a manner that system will have no solution or it will have infinitely many solution, and we have done that. So I hope the procedure is clear, so we can go to the next question. Sample. Investigate for what values of lambda and mu. The system is x plus y plus z is equal to 6, comma x plus 2y plus 3z is equal to 10, and x plus 2y plus lambda z is equal to mu. Have first one no solution, second unique solution, and the third one infinite solution. You can you want to try, or I should solve it?
Sir,
We are
try.
I will try.
We'll try.
Yes, please try. Okay.
So lambda equals to 3 and mu not equals to 10 for no solution.
Oh no, lambda equal to 3 and mu not equal to 10. Okay.
And for
Z.
unique solution, lambda not equals to 3 and mu, any value can be taken.
Okay. Yes, some of the students I can see you are posting your roll numbers on the chat window, but there's no need of it. I have an application which downloads all the present students with their duration, how much time they have attended. So there's no need of putting your roll numbers in chat box.
And so for infinite solution, lambda equals to 3 and mu equals to 10.
Okay. Others? आयुष गोस्वामी
Yes, sir.
क्या?
कहाँ तक पहुँचे हो आगे एक
Sir,
condition
no solution or infinitely solution आ गया.
क्या आया है
Sir, no solution का lambda not equals to 3 or mu not equals to 2.
okay both are not equal to
हाँ sir.
okay
So for unique solution, lambda is not equals to 3 and mu would be any real number. And for infinite number of solutions, lambda would be equals to lambda equals to 3 and mu equals to 10.
yes exactly okay so I'll just write down this final solutions as stated both all those solutions that Ananya and Preeti have got are correct so no solution lambda is equal to 3 mu not equal to 10 for unique lambda is not equal to 3 mu can be simply belonging to the set of real numbers and third one infinite solutions lambda is equal to 3 and mu is equal to 10 if anyone has any problem you can ask
Sir, what condition would it be if lambda isn't equal to 3 and mu is equal to 10?
lambda is
What condition would it be if lambda isn't equal to 3 and mu is equal to 10?
then it will have unique solution na? Look in that case what you are going to get is a matrix
So our
like
rank would be 3, right?
yes rank will be 3 and which is equal to number of variables
Mm-hmm.
so it will have unique solution
Okay.
look that's what I'm trying to explain here just a minute so you have
Sir.
got a matrix like this just a minute so you have got say lambda minus 3 over here
Yes.
and on the right hand side you have mu minus 10
10 minus 1.
10 minus mu minus 10 okay I'll put minus sign over here so this is the kind of matrix if lambda is not equal to 3
Hmm.
then this term won't be equal to 0 and which makes rank of A as well as augmented matrix equal with 3 as their common rank and it doesn't matter what is here
Okay.
okay so in any of the case it will have unique solution
Sir,
Huh.
sir, I have doubt. If
What?
the lambda is equal to 3 and mu not equal to 10, it has to be no solution, na? Because the
Yes.
equation second and third are equal, and that's why 10 is equal to not 10 are coming there.
ठीक है ना that's what I have written here lambda is equal to 3 mu not equal to 10 will have
No,
a
sir.
lambda is
Okay,
equal
okay.
to okay next question this is the last type I want to discuss before that I would like to okay write down the question and then we will frame those equations using The loop current method. The loop current method on a circuit. The following equations are obtained. The equations are 7 I1 minus 4 I2 is equal to 12 minus 4 I1 plus 12 I2 minus 6 I3 is equal to 0. The third equation is minus 6 I2 plus 14 I3 is equal to 0. Solve for I1, I2, I3. Please do it.
Sir, rank of A is equal to rank of augmented matrix is equal to 3.
Yes, what is the value? What are the values?
Sir, I3 is equals to minus 2 by 11.
No, you got it really simple.
I3 is equals to 0.
Okay.
I2 is equals to minus 12 by 17 and I1 is equals to minus 36 by 17.
I think it is wrong. Anyway, I will give you the final solution. The reason why I took that example was I wanted to make a linear equation out of an electrical circuit. So I will concentrate on that by giving you the solutions for this. The solution is I1 is equal to 396 divided by 175. I2 is equal to 24 by 25 and I3 is equal to 72 by 175. Okay, so your electrical circuit problems can be solved very much efficiently or by using linear equation, making a system of linear equations out of an electrical circuit. And how do we do that is the two basic rules. Before going to those two basic rules, I will make a electrical circuit. Okay. The battery is of not able 22 volts and this is 60. This is 4 ohms, 3 resistance, 1 ohm. Fine. Now there are two basic laws that we use here. The one is Kirchhoff's voltage law, and the other is Kirchhoff's current law. So one law says that these are the two junctions, right? The point, I will call this A and B. One law says that the incoming current and outgoing current both are same. Okay, so if I say at point A, what do we get? The incoming current as well as the outgoing current. The incoming is I2, I1 is also incoming, and I3 is outgoing. So I1 plus I2 will actually be equal to I3. And at point B, what we will have? The incoming is I3, outgoing are I1 and I2. So it gives me the same equation. So I3 is equal to I1 plus I2. I'll call this equation number 1. This another law that I need, the voltage drop across any resistance is equal to voltage drop across any resistor is equal to anyone? No one. What is the voltage drop across a resistor?
Zero.
I to R.
I into R. Okay. So voltage drop across a resistor is equal to I into R. So now what we have to do is we have to consider a loop. The law is like this. In a closed loop, voltage drop across a resistor is equal to the total voltage drop across all the resistors is equal to the applied EMF. So in this case, what will happen is, so I'll consider this loop like this, and in this loop, uh, 2 times I1 is the voltage drop plus in this I3, 1 into I3. Oh, I'm so sorry. I1 is passing through these two resistors of 2 each. So what this will be equal to? 2 plus 2 times I1 plus I3 is equal to the applied EMF, that is 16. The everyone is clear with this step? If you have any problem, you can ask right now. And the other loop I will consider, it is like this, the lower one. So in this loop, the current I2 is passing through only one resistor, that is a 4 ohms. So 4 into I2. I3 is passing through one resistor, that is 1 into I3. The applied is 22. So this equation is simply 4 times I1 plus I3 is equal to 16, equation number 2. And the third one is 4 times I2 plus I3 is equal to 22, equation number 3. So solving 1, 2 and 3, we get I1, I2, I3. Okay, that is one of the application of the system of linear equation to electrical circuits. If you have done this kind of examples, then you must be knowing that there is another way of solving, that this I3 value I can substitute in one of the equation and I can solve it. That is also one of the way. But if I want to solve it through linear equation, this is how we do it. If anyone is not clear with the laws that I have used, still you can ask and I will repeat those laws. Okay. So if everyone is clear, I can simply give you another circuit and you can make the system of equations out of it. So I3, this is 12 volts, ohm, sorry. This is 4 ohms. This is 12 volts plus minus, and the currents are 1, I1. Here you have the other one, I2. Third one is I3. Yes. Please make a system of equations out of this. Try making equations out of this. So first task is you look at the junction, okay, and make an equation from the junction that the incoming current will be equal to the outgoing current. A simple logic. Make the first equation from it. Rishabh Singh.
Yes, sir.
Yes. What is the first equation? Don't know.
Yes, sir.
What is the first equation?
So may I?
Yes, Prabal.
So 4i plus 12i minus 24 minus 12 equals 0.
Just a minute. 4i.
So plus 12i plus minus 4i plus 12i minus 24
It's not
b.
simply I. There is I1, I2, I3. You have to make that categorization, or there will be simply one variable throughout the
Sure,
equation.
sir. So 4i1 plus 12i1 minus 4i1 plus 12 4i1 plus 12i2 minus 24 volt minus 12 volt equals 0.
Minus 24 volt.
Minus 12 volt equals 0.
Okay. Fine.
Sir, I1 equal to 12 volt.
Who said I1 is equal to 12 volt? This is correct.
Yes, sir.
Actually.
I1 equal to 12, I2 equal to minus 1 ampere.
How you got it?
Sir, I made two equations and solved it.
Can you tell me the equations, Arthur?
Yes, sir.
Which
Sir, first
loop
one
is-
is, sir, left one loop first.
Okay, this one.
Yes, sir.
Tell me.
Sir, it will be 36 equal to 4I1 plus 12I2.
36, 12, 36 exactly is equal to
Equal to 4I1 plus 12I2.
4i1 plus 12i2. Yes.
Sir, next one will be 24 equal to 8I1 plus 20I2.
24 is equal to 8
I1
No. From this resistor I3 is passing, है ना? So it has to be 8 I3 plus.
Sir, I substituted I3 into I1 and I2.
Okay, that's what you have done. Fine.
Yes, sir.
Sir,
Okay,
may I tell the other equation? Sir,
Yes.
sir, 12I2 minus 8I3 equals to 24.
12 I2 minus 8 I3
equals to 24.
Sir, it will be plus.
I3, yes.
It will be plus.
No, it is correct. The direction you have to mention, I mean, take into consideration. So,
Sir, I2 is equals to 26 by 11.
I don't have actually the final answers with me right now. But equations are like this. I mean, there are two ways to do this. Either you can consider the second loop like this, and the first loop the complete one like this, in which the second part I can simply exclude. So like the first one, Sarthak said that he has took this loop, the smaller ones, two of them. So in any of the ways you can do it. So fine, I think everyone is comfortable with this now. And it's quite late to start with the new topic. So
So just a doubt, like in the first equation, is it 34, 36? 36.
this one, it has to be
It should be
36.
36.
36.
Yes, it is 36. Fine. There is just one categorization that we want to make, and which is a very important remark, I should say, as compared to competitive exams. And the remark is like this. A is n by n matrix, x is equal to 0. So you have seen it in 12th standard that Ax is equal to 0. This type of system of equation is called anyone? Do you know this? What we saw till now is Ax equal to b is the system of equation. Now I'm saying that don't consider this b arbitrary, make it 0. So such system of equation is called homogeneous system of equation. What can you say about consistency of this? You have a homogeneous system of equation. What can you say about consistency of a homogeneous system of equation? For understanding, better understanding, or getting a view of the same, what I will do is I will write down a system of equation. A11, A12, A13, A21, A2.
Sir, consistent may be and unique solutions.
Just a minute. Who said it? Okay.
Daksh.
So the third one is A31, A32, A33, Y, Z, and being homogeneous, right hand side is 0. So now my question is, if you have this kind of system of equation, what can you say about consistency of this? So Daksh is saying that it will have a unique solution, consistent and unique solution.
Sir, as there is at least one free variable, so it will have infinitely many solutions.
Yes, sir.
Will it-
Consistent and infinitely many solutions.
Always.
Not always, if it has free variables.
Gaurav, what you want to say?
Sir, it will be always consistent
Huh?
because the solution will be here trivial, means ax is equals to 0, so we can say that for the values of x the solution will be 0.
Okay, that is a very important point and very good. So I can you can always put x y z as 0 and it is always a solution. I mean, that is always the case. You can put all the variables 0 and it is a solution. So what we will make is what comment we will make is, if a system of equation is homogeneous, then it is always consistent. Homogeneous system cannot, I mean, the case won't occur when the system is non-homogeneous and it has no solution. A homogeneous system always has a solution. Now the question arises, if it has a solution, there can be two types always: a unique and infinite. Unique and infinite. So what we have to do is we just have to figure out now which one it is, either it is unique or it is infinite, that we can do. So we'll just make that remark that homogeneous system of equation is always consistent.
सर अगर उसमें एक फ्री वेरिएबल होगा तो इनफाइनाइट सॉल्यूशन बनेगा ना?
हाँ, बट कंसिस्टेंसी पे रिमार्क चाहिए था ना हमें, मतलब वो तो उसमें भी ट्रू है, नॉन होमोजेनियस में भी है ना. If there is one variable free in even in non-homogeneous system, then it also has infinitely many solutions. So what is important about homogeneous is that it is always having a solution, which is not true in non-homogeneous. Homogeneous system, ax equal to 0 always has a solution.
Okay, thank you, sir.
So homogeneous system of equation ax equal to 0 always consistent. Okay, now I will again ask one more question. If A is a square matrix, then can you determine a case when it will have a unique solution?
Sir, can you repeat?
So if A is a square matrix, then can you determine a case when the system will have a unique solution? I just want a condition when the system will have unique solution. For a
Sir, the rank of A will be n.
Yes, which means that?
Sir, for unique solution.
What can you say about determinant of a matrix with rank n?
Sir,
So it
always
should be an
non-zero.
invertible matrix.
It has to
Sir,
be
the,
invertible.
sir, and the determinant should be always non-zero for unique solution.
Yes, but
Yes,
I'm
sir.
asking, can you relate a matrix A of order n and its determinant? Can it happen that rank is n and determinant is 0? Can it happen?
If the determinant is 0, then it would be a infinite. Then it would give infinite many solutions.
No. With my question, Daksh, is can it happen that rank of a matrix is n and determinant is 0?
Yes, sir.
It
No,
can
sir, I
happen.
think.
No, sir. No.
No, sir. No.
No, sir.
Why no?
So because even if we have a single, if the rank is in, we will have a single digit in any in a row which will have the other values whose values can be zero, but still we will have a determinant's value upon performing the determinant like cross section, cross
Okay.
multiplications.
I mean, you're on correct right track, but not exactly right. I'm in search of some other answer. Anyone else?
Sir, rank can be any positive number, right?
Yes.
Then it is possible. Like consider the matrix, suppose 3 by 3 matrix of 1 0 0 0 0 0 and 0 0 0.
Uh,
So here rank will be 1
uh,
and then determinant will be 0.
okay. No, but not correct. Rank is becoming one. My
Yes.
question is, rank is full. मतलब जो order है उतनी rank है उसकी.
Okay,
Then
okay.
then can it happen that rank is n and determinant is 0? I will just write
No,
it.
sir.
Yes.
Sir, I think for giving us the rank any number, it can't be an infinite many solution. And if determinant is zero, it will be an infinite many solution. So these two
No,
sentence.
look, what I am trying to relate is rank of a matrix and its determinant. What you are doing is you are talking about rank and solutions. My question is apart from system of linear equation. It is from the basics of the rank.
So,
Sir, it won't be possible if rank is full.
It won't.
So unless until the rank is n minus one, we possibly there are good chances that we cannot possibly have a determinant equals to zero. Unless
Okay.
until we have the rank equals n minus one or
Okay,
less.
just a minute.
hello,
Just
sir.
a minute now. Let
Uh,
me just come to someone else.
hello, sir.
Satish.
So if we take a 3 by 3 matrix, then according to the question will be like the or rank is 3, but the determinant can't be 0.
Rank is 3, then determinant can't be 0.
Yes, because if we consider that the rank is 3, so if we convert it into echelons form, the first row will have no zeros. The second row will have at least 1 0 in it.
No. That's
Sir?
not the approach. Okay.
Sir?
Yes, Mohit.
Sir, I think it can be 0. Because, sir, for rank to be 3, there it should only be one minor. So it could be possible that the first, A33 minor should not be 0 and the rest are 0. So in that case, it should be possible.
Sir,
Just a minute now.
Sir.
Just a minute. Let me just check who is it. Yes, wait a minute. Just write down this remark. I'll download the attendance. Our time is actually over. I'm happy to make the discussion, but you will have to go to the basics of the rank if you want to understand this. Okay, what I am trying to get to. So I will write down the question, and if there is something I'll discuss right now, or else you can come by tomorrow and give me some solution. I'll write down the question. Is it possible that is it possible for a n by n matrix to have rank of A as n and determinant of A is equal to 0? So you can
Sir, Sir, it can be possible because it's like the matrix 1 minus 1 minus 1, 1 1 1 and minus 1 1 1. The determinants is coming out to be 0.
So one more answer. If the rows are linearly independent, then like if we determinant of A is not equals to 0, if the rows are linearly independent, if rank of A is n, like
You are reading some book?
no sir.
Okay. So,
Sir, if the rank is n, then determinant can be 0.
Can be 0, sir.
no.
I have a example.
Okay, just a minute, huh? Whoever is done, I mean, if you're not interested, you can leave the discussion. I have downloaded the attendance. Yes, now, Saurav.
Sir, I have example. The matrix 1 minus 1 minus 1, 1 1 1 and minus 1 1 1 has determinant coming as 0.
Okay, and what is the rank?
Rank is 3 by 3.
No, no, you're telling me the order of the matrix, not the rank.
Rank is 9.
How can a matrix of order 3 can have rank 9?
Not possible.
Not possible.
I have a solution.
Who is it?
Mayank.
Yes, please speak, Mayank.
Sir, if we take any matrix of any order, then if we reduce it to a normal form to find the rank, then it has to be an n rank only, sir. If it is less than n, then any row or column will become 0. Then the determinant will be 0.
No. Okay, if someone is writing the notes, you can go to the basic definition of rank. Who don't have the notes, they can simply Google it. On the Wikipedia, you will find a basic definition of rank. Take 2 minutes, read it, and then try to answer this. I'm 80% sure, 80-90% that you will get the answer after that. The first definition of rank that I have written, recall it or Google it. On Wikipedia, it must be there.
सर नो होगा
हाँ, नो रीजन क्या है फिर?
सर वो माइनर डिटर्मिनेंट वाला मेथड था स्टार्टिंग में, तो
हाँ, तो क्या था वो?
उसमें डिटर्मिनेंट अगर 0 होती है तो फिर रैंक उस ऑर्डर की नहीं होती है, फिर अपन को दूसरे मतलब 0 करके दो रो या कॉलम से करना पड़ता है.
Read the definition first.
Sir,
answer will be non-zero.
Sir,
Sir, it is written that in the notes there is at least one minor of order 1 which is non-zero.
That is the answer for the first example. Is not the definition that you are reading.
Okay, sir.
Okay, where is Ananya? Is she there or she has left?
Yes, sir.
Tell me, Ananya. Is it possible?
Actually, I was finding examples.
Okay. So can I come in, sir?
Search matrix.
Yes, Satej.
So I think that if we consider an example, let's consider it's a matrix of 3 by 3. So by this condition, the rank should be of 3.
Why?
No, we are considering if the rank is equal to n, then the determinant 0. So the rank is 3. So if we try to find the rank by equivalence form, the rows, the first row should consist all the numbers.
No, don't go to echelon form. Look at the first definition.
Sir, can I?
Yes, Anirudh.
Sir, in starting you have told that if rank of a matrix is n, so the means it is sir means sir let us consider an example, a 3 by 3 matrix, if minor of order 3 is 0 means determinant A equals to 0, then we will go to minor of order 2 and it should be non-zero, so therefore rank will be 2. Therefore, sir, minor of order 3 should be not equals to 0.
Excuse me, sir.
For being means rank no, if rank equals to n, therefore determinant should not be equals to 0.
Sir, you had initially given a definition in the notes
Def-
that a square matrix of n cross n order is non-singular, then only its rank is equal to n. So that's why
Okay.
it is not.
Okay, that is a remark. Fine. Any other answer? Prabha? And Preeti?
Determinant.
Yes, Preeti.
The determinant would be non-zero because if the rank of A is taken as M, suppose we take it M, and if M is the size of largest non-zero, M cross M submatrix. So it would be a non-zero determinant now.
Okay. Prabal?
Sir, it is not possible to get the determinant 0 when rank of n cross n is n.
Okay, I will write down the solution now.
One sec.
No
सर
sir,
माइनर
no sir, wait.
मैट्रिक्स से होगा ना
Sir, if
क्योंकि डेटा जीरो
determinant
होता है तो फिर रैंक वो माइनर लेके उसके निकालते हैं.
हाँ, माइनर से निकालते हैं, but the definition says that highest minor whose determinant is not equal to 0 is the rank.
ऐसा क्यों करता है तू?
अभी उसका डेफिनेशन है इसलिए ऐसा होता है दक्ष. So whenever there is a minor, I mean of determinant not equal to 0, highest minor जो भी है in a matrix with determinant not equal to 0 is the rank. मतलब we have seen there 2 to 3 examples. Yes, Daksh, wait. So we have seen some examples where we have a minor, say whole matrix determinant turns out to be 0, then you look at minors of order 2, then you look at the determinants if there is some minor of order not equal to 0. तो अगर पूरे मैट्रिक्स का डिटर्मिनेंट ही not equal to 0 है, then that is the highest minor, so it will become the rank. Am I clear?
Sir.
Yes. So that is the idea there you have to use. Okay, I'll just go back to the previous one. So the definition is like this: minor order of highest minor of a matrix which is non-zero. So rank is nothing but the order of minor which is non-zero. I mean to say if you have a say n by n matrix, अगर ये मैट्रिक्स का डिटर्मिनेंट ही नॉन जीरो है, then this is the highest minor whose which is non-zero, so that will become the rank. If the determinant of A is 0, then we go to minors of order n minus 1. n minus 1 के orders check करेंगे उसमें अगर कोई non-zero है क्या, and in that case the rank will become n minus 1. So I hope it is clear now. So if the determinant is not equal to 0, then rank is n. Am I clear, or you have any doubt?
Sir, clear.
Clear, sir.
Yeah.
Yes, sir.
Okay, we'll stop here then.
Sir, one doubt please.
Yes.
Sir, is this correct?